today topic is strain gauge. Strain gauge is the next type of the transducer which is used to measure the force or the pressure. Strain gauge is one of the most popular type of the transducer. It has got a wide range of application. It can be used for the measurement of the force, torque, pressure, acceleration and many other parameters. So by using the strain gauge, we can measure the force, torque, pressure, acceleration, and so many other parameters. The basic principle of the operation of strain gauge is simple. When strain is applied to a thin metallic wire, its dimension changes, thus changing the resistance of the wire. As we know that for any conducting wire having length L, cross section area A, having resistivity rho, then we get the value of the resistance is equal to rho L by A. If any one parameter is changed, then resistance of that wire will be changed. So here also when we apply the strain to the metallic wire, then its value the parameters well changes and the value of the resistance is also changes. So these parameters changes only due to the application of the force, so which can be measured in the form of the change in the resistance. So where the resistance is changed, then the force can be measured here. Now the quantity is the gauge factor. Gauge factor is the important parameter which is used to measure the change in resistance on the application of the strain on a metallic wire. Let us consider a long metallic wire of length L, circular cross section with diameter D. When this wire is subjected to a force applied at the two ends, a strain will be generated. As a result, dimension will change, that is L changing to L plus delta L, D changing to D plus delta D, and A changing to A plus delta A. From the beginning we have considered that all the change in the positive direction. Now the resistance of the wire. So here the figure shown that we take the conducting wire having the length L and the diameter D, and after the application of the force or strain, the change in length is delta L. As we know, the resistance of the wire is given by R is equal to rho L by A, where rho is the resistivity. From the above equation, the change in resistance due to strain, that is delta R, is the part here the total differentiation, which is calculated by the formula delta R upon del into delta L plus del R upon del A delta A plus del R upon del P delta P. And by using the formula, that is we differentiate with respect to the L, A and rho, we get the accordingly delta R upon delta L, delta R upon delta A, delta R upon delta rho, and put in the equation. And then after rearranging we and finally we get delta R upon R is equal to delta L upon L minus delta A upon A plus delta rho upon rho. Now for the cross section area, as we know that for any circular cross section area, the area is given by pi r square, and that is in form of diameter, that is pi d square upon 4, from which again differentiate with respect to d, we get delta A is equal to pi d upon 2 delta A alternately. And when we divide the A on both sides after calculation, and we get delta A upon A is equal to 2 delta D upon D. Now put delta A upon D in the equation number 6, that is the equation of the delta R upon R. Hence we get delta R upon R equal to delta L upon L minus 2 delta D upon D plus delta rho upon rho. Now the Poisson ratio is defined by, that is V is equal to lateral strain upon longitudinal strain. That is lateral strain mainly is along the diameter of the any metallic wire, that is delta D upon D, that is change in diameter upon original diameter, and longitudinal strain, that is change in length upon original length. And the Poisson ratio is a property of the material that not depend upon dimension, so can be written as delta R upon R is equal to 1 plus 2 V delta L upon L plus delta rho upon rho. Then we take out delta R upon delta L upon L, and finally we get delta R upon delta L upon L is equal to 1 plus 2V upon delta rho plus delta L upon rho. And this is last term in the right hand side of the above expression represent the change in resistivity of the material and due to the applied strain and occur due to the piezo resistance property of the material. As we know, rho is the parameter of the wire which cannot be changed, only the length and area change and resistance change. But in this case we also consider the change in resistivity due to the application of the strain, so mainly due to the property of the piezo resistance property of the material. So in this case and here piezo resistance property is considered. In fact, all the elements in the right hand side of above equation are independent of the geometry of the wire and subjected to strain, but rather depend on the material property of the wire. तो हमारे जितने भी इक्वेशन राइट हैंड साइड में हैं इट इज़ इंडिपेंडेंट ऑफ द ज्योमेट्री ऑफ द वायर, बट इट डिपेंड अपॉन द मटेरियल प्रॉपर्टी. मटेरियल प्रॉपर्टी मीन्स दैट इज रो, the material property of the wire. Due to this reason, the term gauge factor is used to change the performance of strength. That gauge factor is defined as G is equal to delta R upon R plus delta L upon L is equal to 1 plus 2 V plus delta rho upon delta L upon L. For normal metal, the Poisson ratio that is varies from 0.3 to 0.6, and while the piezo resistance coefficient varies from that is 0.2 to 0.6. And after putting these value of the that is Poisson ratio V and delta rho and upon delta L upon L, and put the value of the minimum value and maximum value, then gauge factor of the metallic strain gauge is also ranges from that is 1.8 to 2.6. Then again, this is all about the strain gauge. Here the force can be measured with the parameter gauge factor. This is all about the strain gauge.